Well, hello everybody. We're going to begin our notes on electron configuration. And let me zoom out. So, to begin with, we're going to call this part A, and we're going to call this shells to energy levels to suborbitals. So we've talked about shells to energy levels. These are all the names of the outer part of the atom that have evolved over the last couple hundred years. And then energy levels to suborbitals. Shells to energy levels to suborbitals. Because it's not just as easy as, first imagine that, okay, there's a nucleus and then there's a shell. No, it's a little more complicated. We found out there were more than one shells, and now we're finding out that even these shells, if we take a look at one of these shells, if we can pull it out, it's not just one shell, it's actually three subshells, or what we might call three suborbitals. So, let's go here, number one. Under this, atoms have up to 7 shells. Atoms have up to 7 shells, or orbitals, or energy levels. When we look on the periodic table, we see that there are 7 periods on the periodic table, and that correlates to each of the 7 shells that the atom has, and those guys are actually part of 6 and 7. Okay, so atoms have up to 7 shells. That's what we've been talking about up to now. Let's draw a couple of these just to kind of touch base. We'll do a modified Bohr model. We'll do hydrogen. Our friend hydrogen has 1 shell. It's in the first period, and it has just 1 little electron there. Okay, that's easy. That's why hydrogen's so nice to work with. It should be easy, but it can actually be pretty complicated. Anyway, we don't care. Lithium. Let's go down now we're just going down to the second period. Well, now that means that lithium has 2 shells, and it has 2 electrons in that first shell, and it has 1 electron in its second shell. Okay, so far, that's okay. Now we're going to do sodium. Sodium is in period 3. And up to now we've said, okay, sodium's going to have 2 electrons in the first shell. In the next shell, 8 electrons. And then in its third shell, just 1 electron sitting there. So I'm kind of going back and forth between dots and numbers, but there we go, 8 electrons. Now let's just kind of zoom ahead here a little bit. Okay, let's fast forward. Fast forward to the bottom of the periodic table. You don't have to write this. I'm just, okay. So let's just take a table. So now let's take a look at francium right there. Francium is the largest element in group 1 of the 7th period. So now, when we do this, let's be careful. It's pretty big. So I'm going to do it this way. I'm going to put its nucleus right here. Here's good old francium. Now, francium is in period 7, so that means it's going to have 7 shells. Let's just do part shells here. Okay, well, I'll do the first one here. There's 1. Okay, I'll do that. But now, second shell, third shell, fourth shell, fifth shell, sixth shell, seventh shell. Now, it's just going to take too much, so let's just do this. There are 8 electrons in its second shell. There are 18 electrons in its third shell. It's got 32 electrons in its next shell. In fact, I'm going to extend this one a little bit, just so 32 electrons in there. The next one here has 18 electrons. The second to last shell has 8 electrons, and the outer one, it is in group 1, it has 1 electron. 1, 2, 3, 4, 5. I've got all 7 in there. If we add up all of these electrons on here, it's going to add up to atomic number 87, and that's how many electrons it has. So this is now, we're taking the step away from, because up to now we said the third shell could hold up to 8 electrons. Actually, the third shell can hold up to 18 electrons. And we're going to explain now why we have that little difference on there. So now we're going to go to number 2 in our note. Okay, so this is what we kind of started with. Okay, there can be up to 32 electrons in the outer shells of the, starting in about group, I think it's going to be starting in group 5 is when we start getting to 32. Anyway, number 2, right over here. So you need to pause for a moment if you're watching this at home. Okay, pause. But now we're going to go to most shells overlap. Most shells, orbitals, energy levels, overlap each other. Just they overlap. So let's give yourself some room for this. If you're probably doing this on line paper, I would recommend, give yourself, a third of your paper, because we're going to draw quite a few here. Okay, so I would recommend, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to go down 10 lines, and we're going to start right here. And this is the first shell here, okay? This is going to be shells. But that's really not very good. Let's call it energy levels, because it takes energy, certain amounts of energy to keep these electrons there. Energy levels. And if you're going to go on and take AP chemistry in a year or two, they'll call this N. They call it the N number. Like, for example, this is the N number for the first shell is 1. This is N1. Okay. Anyway, first shell right there. Okay. Now we're going to draw the second shell. So let's just go up one line here. Okay. Now the second shell. Now when we draw this, this is going to split off. We're going to draw it here. The second shell actually has 2 suborbitals. We mentioned that up here at the top, some 2 suborbitals. So we're going to split this now, like this. Draw this over to the line there. Okay, so now we've got, this is our second shell. Up to now we've been told the second shell can hold up to 8 electrons. That is accurate. In fact, let's just put here, 2 electrons can be in the first shell. Now, in the second shell, there is 8 electrons, but the first suborbital has 2 electrons, and then the second part of this, there's actually, they have the second part here, there's up to 6 electrons in that one. Now that adds up to the total of 8. Now we're going to go up, I'd recommend, let's go up 1, 2, let's go about 3 lines. We're going to need some space here. Now we're going to start up to now what we've called the third shell. We're going to find it splits into 3. Imagine that. Hey, look at that. The first shell has 1. The second shell has 2. And this one's going to split into 3. So let's bring this one down here, just above here. And this one, I'm just going to let it go kind of straight. And this one will just come up like that. So you can have 2 electrons in this one. Okay, you can have 6 electrons in this one, and then electrons, and then this one right here, this part here, this is a big one. It can have up to 10 electrons inside of it. Okay, so now so far it's like, okay, there's not a problem. I can get this. It's not too confusing. All right, I'd recommend now with this next one, let's change color pens. Okay, grab a color pencil, get a different color. I'm going to use red just to draw it out a little bit. So now what we're going to do, let's come up here, 1, 2, 3 more lines. Let's do the 4th shell. Okay, so the 4th shell, I'm going to draw it over here. Now, our first one here, we got to be careful. I want to make sure, oh, this isn't too bad. What we're going to do is, this one is going to come down like this. Ooh, right in between the top 2 suborbitals of this one. I know, it's like it's a bummer. It does that, but we just got to deal with it. Then we've got another one coming down like this. We've got one coming straight ahead like that. And then we've got a 4th one. Hey, we're in the 4th shell. It could break into 4ths. That's kind of where that will end now. Now, after this, all the rest of the shells can break into 4s. Okay. So look at this here. Now we've got our first little bit of overlap right here. And you know what? You know what? Just for illustration point. Oh, okay, wait. We can have 2 electrons in this suborbital. We can have 6 electrons right there. Okay, what's the pattern? Before we had 2, 6. What's going to be this one? Okay, we can have 10 electrons. This is just kind of how it works out. And then you can have up here, it's going to end up being 14 electrons there. So now if we do the fifth, you know what? The fifth one. You know what? I would recommend you do not draw this part in. I'm going to show you the fifth one. I'd really recommend you not to do it, just because it's just going to kind of confuse you probably a little bit. But if I draw the fifth one, I got to squeeze it in. So please, I recommend don't you do it. This pen's too thick. I will not use this pen. I will use another. Okay. Oh, wait a minute. Wait, hold on. Sorry. I thought I had it set up. Here we go. So now don't do this. Just so you can see. So what we got to do is the fifth. Now I'm only going to draw the bottom 2 on the fifth, and what's going to happen is we get one that comes right here, all right, and then we get the other one that comes right there. Now again, don't, for your, I'm just saying, I'd recommend you not do that. This, this 2 electrons in this one, you can have 6 electrons in that one. So now what you can start to see is that these orbitals begin to overlap up there, and it gets kind of confusing. It can get kind of confusing. There's a neat little way we can get around that. So we've now come from the part where we learned earlier that you've got shells, and that there's 7 shells. Now we know that the shells are broken into suborbitals, and those subshells, those suborbitals, they can overlap. I think I'm going to use the term, I'm going to call these subshells. We've got 2 subshells, 3 subshells, 4 subshells, because those subshells are going to be made out of what I'm going to call suborbitals to get the term right. So with that, I'm going to pause this right here, because this is just the first part, but I will say toodles.